And we are streaming live.
Hey people, very good afternoon. I
Hello,
hope you can
ma'am.
hear me. Can you? Can you hear me, people? Am I audible? Hi,
Yes,
Aditya.
ma'am.
Good afternoon. Am I audible? Yes,
Yes,
thank you,
ma'am.
Sujita. Okay. All
Good
right. We'll just
ma'am.
wait for another 2 minutes. Let everybody join in.
Good afternoon, ma'am. Bad.
Okay. Good afternoon, Anjali. So anybody had taken any practice test? Anybody had taken any practice test? One minute. Hi, Sangali. Good afternoon. Durgesh, good afternoon. Good afternoon, everybody. Okay, let's start then. Let everybody join whenever they want to join. Okay. So we will start with probability today. Shall we start with probability or syllogism? What do you want to start with? Let me just go on YouTube also. Where to take practice test? Practice test is on website. Hi, Afin. Hi, formula. Okay, probability. Fine, either. Okay. Hi, good morning, Jennifer. Fine. Hi, Mercy. I just want to wait another 1 minute because when I'm starting a new topic, I want, in case if people wants to join, they will join. Okay, let's start then. So share the screen. Can you see the screen? Hi, Surjo. Can you see the screen? Let me zoom it. All right, thank you. So we have discussed all these questions. I will come back to all these questions because every probability question can be converted into, every permutation question can be converted to probability question. Okay. So what is probability? What do you mean by probability? Anybody? What do you mean by probability? What do you mean by probability? Anyone? Anyone? Anybody know what is probability? Chances of selection. Correct. So I can say that probability is uh, in a very simple word, in this very simple term, probability of happening something, probability of chances, chances of something, right, Muka, right, Surjo. So favorable events upon total events. This is how I go ahead with probability is equal to favorable upon total. When I say if I have tossed one coin, let's say you have tossed one coin, what will be a total number of outcomes? What will be the total number of outcomes when one coin is tossed? What will be the total number of outcomes? Total number of outcomes will be 2, right? Now, let's say probability of getting a tail, probability of getting a tail. So one tail, right? And you will get one tail. So your answer will be what? 1 by 2. So probability of getting a tail will become your favorable event. And in denominator, it will be your total number of events, right? So when you talk about probability, the cases which they discuss is the cases which they discuss or the kind of question they ask is on coins, is on cards, is on dice. Could be on balls also. Am I not audible? Audible. Just check at your end. Kindly adjust your mic. My mic. Now it should be better. Maybe there is a problem in Zambia then. Okay. All right. So cards, dice, it could be a number of balls. So we will discuss about all this. Right. Before that, let's look at each question of permutation combination which we did, how it could be into form of, how could this be in the form of probability. So in how many ways can the letter of the word, in how many ways can the letter of the letter of the word dealer be arranged? So we know that the total cases is what? 360. Now, the question is in the word dealer, what is the probability that vowels are always together? This is probability question. What is the probability of vowels always together? Vowels always together. Probability of vowels always together in the word dealer. In the word dealer. What would be your answer? 1 by 120. Okay. I don't know the answer. Let's solve then. So In denominator, it will be what? Total number of term 1, 2, 3, 4, 5, 6, 6 factorial by 2 factorial. Whatever the total cases, that will be in denominator 6 factorial by 2 factorial. Is that clear? 6 factorial by 2 factorial will be your denominator. Is that clear? Yes. Okay. Now in numerator, what it would be? In numerator, they are saying that the favorable condition they are asking is vowels always together. That's the favorable condition. So D, E, A, L, E, R. So we need to consider this as one unit. So 1, 2, 3, 4, four-letter word can be arranged in 4 factorial ways. These 3 letters can be arranged in 3 factorial ways. And is there any repetition? Yes. So divide by 2 factorial. So this part should come in numerator 4 factorial into 3 factorial by 2 factorial. So this 2 factorial will get cancelled out. Your answer will be 4 factorial into 3 factorial by 6 factorial. Is that clear? Is that clear? Yes. All of you understood? Fine. So what would be the Saroj? Let's look at this question. The same thing. In how many different ways can the letter of the word mathematics? So what is the probability that letters of the word mathematics be arranged such that vowels are always together? What is the probability that when the letters of the word mathematics be rearranged, that vowels are always together? So we have already solved vowels. All right. Jennifer, look at this. For vowels together, what we need to do? We have to make them as one unit. So A, E, A, I will keep them as one unit. Now 1, 2, 3, 4, 5, 6, 7, 8. 8 letters can be arranged in 8 factorial ways. And is there any repetition in this part? Yes, M is repeating, T is repeating. That's why 2 factorial, 2 factorial. Is that clear so far? Is that part clear? Is that clear? Yes. Now, what is happening? These letters can be rearranged themselves in 4 factorial ways. And as 2 letters are repeating, that's why divide by 2 factorial. So this is a favorable condition that vowels are always together. But now the question is about probability of what is the probability that vowels are always together when the letters of the word mathematics be rearranged. So now what you need to do, you need to divide it by total number of ways it can be arranged. So 11 letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters can be arranged in 11 factorial ways. Now M is repeating, A is repeating, T is repeating twice. So divide by 2 factorial, 2 factorial, 2 factorial. Okay. So this would be your answer. I hope it's clear, Saroj and Jennifer. Don't solve, it's okay. Is the concept getting clear? Yes or no? Yes. Okay. All right. This is the same question. Okay, I was going wrong. Fine. I hope you can solve this question also now. Fine. We'll move to the question. Okay. Fine. In how many ways can 10 boys be arranged in a straight line such that 2 particular boys are never together? So when 10 boys are arranged in a straight line, what is the probability? So the question can be again formed in a probability. What is the probability that boys are always 2 boys are never together? So what is the probability that 2 boys are never together? So we just have to take care of the case. What is the probability when 2 boys are never together? So we will again make them together first, right? So I hope you remember how to solve this. First of all, we'll consider these 2 boys as one unit. We consider these 2 boys as one unit. So now we are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 boys can be arranged in 9 factorial ways, and these 2 boys can be arranged in 2 factorial ways, right? But they're saying that they are never together. Probability. So probability, we'll see that later. are never together. This is for together. So 10 factorial minus this. Right? This is your permutation question, what I have solved here. Now divided by 10 boys are there, can be arranged in 10 factorial ways. So this will become your probability question. Did you understand? All of you got it? Yes, no? Can you reply quickly? Yeah? Okay. All right. Now this is good question. 4-digit number, what is the probability? Probability that 4-digit number is divisible by 2. From the given digits. Given digits are the digits which are given above. Anybody? What would be your denominator? Ten factorial, 9 factorial. No. 9 into 10 into 10. Yes, Dipesh. Your numerator will remain same. Divisible by 2 at the unit digit, it can be 0, 2, 4, 6 or 8. So 5 place 5 number and 9 into 10 into 10, right? So this will be what? This is 9 into 10 into 10 into 5. But if you say that number is not divisible by 2, basically you're looking for all 4-digit numbers. So this place can be filled by 9. This place can be filled by 10. This can be 10. This can be 10 again. So your answer will be 9 into 10 into 10 into 10. This will be your denominator. So see, which is nothing but 1 by 2. Now, how you are getting 1 by 2? You take any number, half of the numbers will be odd and half of the number will be even. Like from 1 to 10, half of the number are odd and half of the number are even. Are you getting my point? Right. If you talk about 1 to 20, again, you have 10 odd numbers, 10 even numbers. If you take 1 to 50, you have 10, you have 25 odd numbers, you have 25 even numbers, right? So that's why the answer is also 1 by 2. Am I making sense? Am I making sense? People on YouTube, are you? I hope you are understanding. Assalamu alaikum. Got it? Fine. So let's move to the next one. All right. So how many 3-digit number can be formed from the digits 2, 3, 5, 6, 7, which are divisible by 5 and none of the digit is repeat? So what is the probability that number is divisible by 5? What is the probability? Okay, let me look at this way. What is the probability? What is the probability that 3-digit number formed from the digits are divisible by 5 and none of the digit is repeated? So what would be your answer in this case? What would be the answer? 5 into 4 into, okay. So the answer will be yes, 5 into 4 into 1, correct. If I talk about favorable cases, this number has to end with 5. So only one place possible, one number possible. This can be 2, 3, 6, 7, 9, like I have already written there. So for this place, we have 5 options. Let's say you have chosen 6. So now you have 2, 3, 7, 9. You have 4 options. So this will be your favorable. That's 5 into 4 into 1. Now, if I have to talk about denominator, denominator could be any number. Like, are you sure it is 5 into 4 into 3? So denominator can be 2, 3, 5, 6, 7, 9. So how many numbers you're getting? 1, 2, 3, 4, 5, 6. One number you selected. 2, 3, 5, 6, 9. 5. Let's say you selected 3. 2, 5, 6, 9. So this is 4. So your denominator will be 6 into 5 into 4. So your answer is 1 by 6. Right, Sivani. So those who are getting 5 into 4 into 3, I hope you understood where you have made the mistake. All right. Got it? Fine. Let's move to the next one. So yeah, what will be the denominator part for this question? What is the denominator part of this question? Out of 7 men and 4 women, how many groups of 3 men and 2 women can be formed? So probability of a group, probability of a group of 3 men and 2 women. Very good. So right, this will be your numerator, 7C3 into 4C2. Now, how many people are there? 7 plus 4, 11. Awesome. And how many people we are selecting? We are selecting 5 people. So your denominator will be 11C5. Flywell, I hope you are understanding too. Jennifer, Srijita, Mercy. Who else is there? Aditya Yadav, Amit Paul, Kumbusu, Nilius, Raj Kasaudan. You came today. Sandali, understanding? Can you reply quickly once to me, people? Getting along? Good, Michelle. Okay. Awesome. Awesome. Fine. Let's move to the next one then. So this also you can do now. This also you can do. In a group of 3 boys and 4 girls, 4 children are to be selected in how many different ways such that at least one boy should be there. So everywhere your denominator will be 10C4 because 4 people you are selecting, 1 boy, 3 girls. So you are selecting 4 people out of 10. So denominator will be 10C4 for this part. Okay. So what will be the denominator for this one? In a plane, there are 20 points of which 7 are collinear. What is the probability of the number of, we will get the number of classes achieved, number of triangles. What is the probability that we'll get the number of triangles? Basically, that question doesn't make sense. So denominator will be simply, actually that question doesn't make sense here. Okay. It doesn't make sense. Or yeah, you can say 20C3 in denominator, maybe. But I'm not, that question is not making sense to me. So we'll see. Okay. Right, let's move to the next one. So what will be your denominator in this part? In how many ways 5 people be arranged in a round table such that two particular people, what is the probability that 2 particular people never sit together? What is the probability that 2 people never sit together? Answer this one, then we'll move to actual cases of probability. Anyone? 4 factorial, absolutely right. Correct. Vinay, it's a circular arrangement, right? Round table, circular arrangement. So when it is circular arrangement, it is n minus 1 factorial. So this will be your numerator. 4 factorial minus 3 factorial into 2 factorial. Again, two people never sit together, so we will make them sit together first. So we will make them sit together. So 1 2 3 4, 4 people. 4 people can be arranged in 3 factorial ways in circular arrangement. So this is 3 factorial. Now these 2 people can be arranged in 2 factorial, so into 2 factorial. But now they are saying never sit together. So for never sit together, we from total we will subtract it. But as it is a probability question, so when it is probability question, we need to divide it by 4 factorial. Fair enough, right? Yeah. Okay. So we'll move on now. So very first case which we will see is coins. So two coins were tossed together, find the probability of. So what's your message? Let's see that first. Ma'am, why we divided by 4 factorial? Surjo, because it was Suraj, it was a question about probability. So if it is probability question in denominator, we need to divide it by total number of cases. So if 5 people are there, 5 people around the circular table can be arranged in 4 factorial ways. Okay, anybody got the answer for this one? If two coins were tossed together, find the probability of. Anyone? It's simple question. 1 by 4. Okay, so exactly one head. How many coins were tossed? Two coins. So I'll get first coin, second coin. Head, 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 tail, tail, right? Now they're saying exactly one head. Exactly one head I'm getting in two cases. Exactly one head I'm getting in two cases. So 2 by out of how many cases? Out of how many cases? 4 cases. So 2 by 4. So your answer is 1 by 2 for this one. Now, at least two head. This is for the first one. At least two heads. At least two heads, how many cases? Only one case out of 4 cases. So for that, answer is 1 by 4. So for this one, answer is 1 by 4. And for this one, answer is 1 by 2. Right? Got it? Yeah. Now I'll tell you the easier way. This is 5 coins. I want you to solve for 3 coins. Same questions for 3 coins. 3 coins. First case, exactly one head. Yeah, same question, Vinay. Exactly one head. And second one, at least two heads. Then I'll tell you the shortcut. First of all, you try. I'm coming to that, Vinay. Wait for a minute. Why are we practicing this though it's not in our syllabus? Rahul, the thing is that we don't know if some question comes in your exam from probability, because when they update it in, this is a part of aptitude or like quantitative aptitudes part, and it's a very important topic though. And I'm really surprised that why they haven't mentioned it in your SI syllabus. So one thing is that might be possible, if they ask you any question, you should be able to solve it. Binay is saying we had seen in previous year. All right, Rahul, you got your question? Answer. Okay, so anybody got the answer for exactly one head? I don't know why I'm saying bun. One head, 1/2. Mhm. So now 3 coins, right? 3 coins answer will be 3/8. And at least 2 heads, your answer will be, okay, I'll make the cases. Head, 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 tail, head, tail, head, tail, 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 head, tail, and head, tail. So exactly one head, one, two, three, 3 cases. So 3 out of 8 cases, your answer is 3/8. At least 2 heads, one, two, three. At least two means could be two or more than two. I forgot one. I did not write. Okay, here it is. Head. Two or more than two. Two or more than two. Two or more than two. Two or more than. So here your answer will be 4/8. That is 1/2. Right? Now let's look at how to solve it in an easy way. Understand one very simple thing. You will understand it super quick. So everyone stay focused. So if there is one coin, there are 2 cases, head or tail. How many outcomes? 2 outcomes. If there are 2 coins, what are total number of outcomes? 2 to the power 2. If there are 3 coins, then what are the total number of outcomes? 2 to the power 3. So if there are 4 coins, what will be the total number of outcomes? What will be the total number of outcomes? 4 coins, 2 to the power 4. 2 to the power 4. So it is number of outcomes to the power number of coins. Number of outcomes to the power number of coins, right? So if there are 5 coins, then your total number of outcomes will be 2 to the power 5. Is that part clear to everyone? Is that clear to everyone? Yeah. Okay. All right. Now, 2 coins, head and tail. Sorry, 1 coin, head and tail. 2 coins, head, tail, tail. 3 coins, head, tail, head, tail, tail, head, tail, tail, head, tail, and head, tail. All right, correct. So now what I want you to understand is, if there is 1 coin, in each of the cases, you're getting one outcome. If there are 2 coins, in each of the cases, you're getting 2 outcomes. If there are 3 coins, in each cases, you are getting 3 outcomes. Is that part clear? Is that clear to you all? Right? So if there are 4 coins, then in each case, you will have what? 4 outcomes. In each case, head, tail, head, tail, like all this continuation. And how many cases you will get? 16 cases. Fine. Is this part clear now? Now, another case. If there are, if the question is given exactly one head, 2 coins, 2 coins, and the question is about exactly one head. 2 coins, and the question is about exactly one head. So now what will happen when they're saying two coins, exactly one head? I can get maximum two outcomes. When two coins are there, I can get either two heads or two tails, right? I'll be getting two heads or two tails. So this will become what? 2C1. I need one head, so I'll get 2C1 divided by what? 2 square. This would be your answer. If three coins were tossed, if three coins were tossed, and the question is about exactly two heads. So if three coins are tossed, how many maximum heads I can get? Maximum number of heads I can get is 3. So out of 3, I need 2. So 3C2 divided by 2 to the power 3. Did you understand? All of you got it? Yes or no? Right? Okay. Now, if the question is given to you about three coins, at least two tails. So at least two tails means what? I can get two tails, or I can get three tails. Two tails or three tails. It could be two tails or three tails. So this is 3C2 plus 3C3 divided by 2 to the power 3. Is that clear? Also, it is something, probability of at least of something, at least is something is equal to 1 minus probability of nothing. This something, nothing could be anything. So if they are asking you probability of three tails, let's say 5 coins were tossed. 5 coins were tossed. Probability of at least three tails. So I will say that, understand this, okay? Understand this. Probability of at least three tails. So when they say that they need at least three tails when 5 coins were tossed, it means that they need three tail, they need four tail, they need five tails. They need all this. What they don't need, what they don't need, what they don't need. 2 and 1 and 0 also. They don't know zero, they don't need zero tail, they don't need one tail, they don't need two tails, right? So probability of at least three tails could be done into this way: three tail or four tail or five tail. So 5C3 plus 5C4 plus 5C5 divided by 2 to the power 5. This is one case. Or you can also say 1 minus 5C0 plus 5C1 plus 5C2 divided by 2 to the power 5. 1 minus probability of nothing. So 1 minus what we don't need. Got it? Understood, right? So I hope it's clear. Yes or no? Yes or no? Yes? All right. So tell me the answer of this question. Just let it be in terms of NCR and in NCR by something. So exactly two head, yes, the answer is 5C2 by 2 to the power 5. 5c2 by 2 to the power 5. You don't have to take screenshot, Afreen. I'll anyway share this file with you all. So whatever I'm writing here, you will get it. For this is the first one, 5c2 by 2 to the power 5. At least 3 heads. Yeah, just now I think we did it. 5c3 plus 5c4 plus 5c5. Raj, I think you have made a typing error. At least 3 heads. So 5c3 plus 5c4 plus 5c5 divided by 2 to the 5. I hope that's clear. Yes. Okay. All right. So we are good. Are we good with this? If the question is given to you, let's say one more. 10 coins, probability of same question. Exactly 2 heads, exactly 2 tails. Let's do one and the same though. And at least 3 tails. 10 coins. Someone's audio is on. I cannot hear. My audio only, Dipesh. And it has to be on. Hi, memory. Where did the question go? 10c2 by 2 to the power 10. Yes, for the first one, yeah, the answer is 10c2 by 2 to the power 10. All right, no problem. How about second one? At least 3 tails. What would be the answer? At least 3 tails. What would be the answer? Ayyo, Raj, you don't have to do this. At least 3 tails means you need 3. They will not ask like that, Rahul. Okay, because think about it. What if they ask at least 2 heads and at least 2 tail sets? So when, see, Rahul, one thing, when, if it is 4 coins, if it is 2 heads, it means that other 2 has to be tails. All right. Now, if there are 10 coins, if they're saying at least 2 heads and at least 2 tails, so this is taking care of at least 2 tails also. Are you getting my point? Iradukunda, what's your problem? Why you are writing hell again and again? Like what you are trying to achieve here? Right, Raj, that makes more sense now. At least 3 tails means 1 minus what we don't need. We don't need 0 tail, we don't need 1 tail, we don't need 2 tails. All right. So 0 tail, 1 tail, 2 tail, 1 minus this. So 1 minus 10c0 plus 10c1 plus 10c2 and divide by 2 to the power 10. Right? That makes more sense, Raj. I hope you also understood then. Ira Dukunda, Eric, can you tell me what's your problem, Ira? If I'm able to help you out, or else you can leave the meeting. I hope this coins problem is clear, people. Is coins problem clear? Right? Okay. We'll move to the next one now. All right. So the now next one is dice problem. Simple one. Very simple stuff. Dice. All right. So dice is like what? You know, right? Dice. You would have played Ludo. Very common game these days. So everyone know about dice? Yes. Anybody who doesn't know dice here? 6 plane, right? 1, 2, 3, 4, 5, 6. Right. 6 plane has 6 faces. Correct. And opposite faces will always sum up as 7. So wherever it is written 1, opposite to that will be 6. Wherever it is written 2, opposite to that will be 5. Wherever there is 3, opposite to that will be 4. This is just one thing. Now, if one dice is thrown, how many outcomes will be there? If one dice is thrown, what will be the total number of outcomes? 6 outcomes. If two dice, then if two dice, 2 to the, sorry, 6 to the power 2. 6 to the power 2, Raj, correct. 6 to the power 2. If 3 dice, then what will be the total number of outcomes? 6 to the power 3. Though in your exam, I don't think so that they will go to 3 dice, because 3 dice question generally becomes very tougher one. So even in CAT exam, they don't ask. So we will be discussing on 2 dice and 1 dice. So when 1 dice is rolled, now answer this quickly. When 1 dice is rolled, what is the probability of when 1 dice is rolled? What is the probability of when 1 dice is rolled? What is the probability of getting number 4? What will be your answer? 1 by 6, right? Okay. When 1 dice is rolled, what is the probability of getting even number? 1 by 3, that is 2 by 6. You will get 2, 4, 6. 2, 4, 6. 3 by 6. 3 by 6 is 1 by 2. Probability of getting prime number. Probability of prime number. Prime number is again 2 is prime number, 3 is prime number, and 5 is prime number. So again, answer is 3 by 6. So that is 1 by 2. Is that clear? Right? Clear to all? Now I'll move to another case. Whenever we talk about 2 dice, majority of the questions on 2 dice are related to the addition. Okay, you will see that. So when 2 dice were rolled, what do you think would be the minimum sum? Like you and I am playing, we are playing. What would be our sum? What sum we can get? What is the minimum sum we can get? 2. When you are getting 1 and I am getting 1. When you are getting 1 and I'm getting 1. Then we can get 3 also. When you are getting 2, I'm getting 1. Or when you are getting 1, I'm getting 2. Understood? Got it, right? So you can get 4 also. When both of us are getting 2, 2, or you got 3, I got 1, or you got 1, I got 3. So we can get 5, 6, 7, 8, 9, 10, 11, 12. So in which all situation we can get 12? When you getting 6, I'm getting 6. 5, 11 we will get when you getting 5, I'm getting 6, or when you getting 6, I'm getting 5. 10 we will get when both of us are getting 5, 5, or one of us is getting 6, 4, or 4, 6 interchangeably. So for 2, how many cases you are getting? For 2, how many cases you got? 1. For 12 also, how many cases you got? 1. For 3, how many cases you got? 2. For 11 also, how many cases you got? 2. For 4, how many cases? 3. For 10, how many cases? 3. So similarly for 5, how many cases you will get? Can anyone tell me now? 1, 2, 3, 4. So if this is 4, this will also be 4. If this is 5, then this will also be 5. And then this one is 6. All right. So this is like, I remember it is in a garland way, a very simple way for me to, 1 minute, there's something happening with chat window. Okay. So now how I remember this, how I will write it as. So this I'll write summation. Summation could be what? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? This could be your summation. Fair enough? I don't know how. Right now, we'll write the cases. Cases for 2 is 1, 2, 3, 4, 5, 6. 5, 4, 3, 2, 1. When you will add this, you will get 36. Got it? Okay. So now if the question is when two dice were rolled, what is the probability of getting sum as 4? What is the probability of getting sum as 4? Your answer will be what? Directly 3 by 36. Does that make sense? Okay. All right. So let's look at the questions now. So getting sum as 4. This is getting sum as 4. Find the probability of getting sum as 4. What would be your answer? Just now we did, right? Getting sum as 4. Just now we did 3 by 36. All right. Sum as prime number. So sum as prime number. Any answer? Anybody? 10 by 36, I think answer is 15 by 36. So sum is prime number. I write quickly here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So now they are saying it has to be what? Prime numbers. So what are prime numbers? 1, 2, 3, 4, 5. So for 2 it is 1, for 3 it is 2, for 5 it is 4. So add all this. 1 plus 2, 3 plus 4, 7 plus 6, 13. 13 plus 2, 15. So your answer is 15 by 36. We need to add all this number. 1 plus 2 plus 4, 7 plus 6, 13 plus 2, 15. Answer is 15 by 36. Is that clear? Got it? Okay. Next one. Both even numbers. We will come to this little later. Getting a pair. How many we will get a pair? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. All right. So we will get how many pairs? We will get 6 pairs. So your answer for this one will be 6 by 36. That is 1 by 6. Is that clear? Now, getting the sum is multiple of 3. Getting the sum is multiple of 3. Multiple of 3. 3, 6, 9, 12. The cases for 3. 2. The cases for 6. 5. The cases for 9. 4. The cases for 12. 1. 2 plus 5 plus 4 plus 1. 7 plus 5 is 12 by 36. That's 1 by 3 is your answer. So answer for this is 1 by 3. I hope it's clear. Right? I want you to try this one. Both even numbers. Try once. Try once. Both even numbers. No Mukha. Aditya, for which one? For both as even numbers? Okay. So both even numbers, it means like you should get even number, I should also get even number, right? Both of us should get even number. Agree? You should get even number, I should get also get even number. How many even numbers you can get? 3 times out of 6? How many even numbers I can get? 3 times out of 6. So your answer is what? 9 by 6, 9 by 36. 1 by 4 is the answer. Okay, I'll tell you in a very simple way. What are the possibility? You getting odd number, I'm getting odd number. You getting odd number, I'm getting even number. You getting even number, I am getting odd number, or both of us getting even number. So one case out of how many cases? 4 cases. So the answer is 1 by 4. Did you understand? Got it? Understood, right? I hope you got it and you found it easy. Fine, we'll move to the next one then. So we are done with the dice problem also. Dice problems will be like this, people. Mostly you can expect the dice problem on addition. All right. Okay, fine. Let's move to card problems. Now, card problem is, how many of you know cards? How many of you know cards? How many of you don't know cards? You don't know, Binay. Okay. How about others? I'll show you the. Oh, you also don't know? Okay, fine. Playing card picks. All right. 1 minute. Okay. So I'll share the screen. If you don't know, fine. Understand one very simple term. I'll share the screen also. So first of all, can you see the screen? I wanted to share probability. Okay, can you see the screen? You know about cards? Awesome, Anu. Okay, now here I'll show you the screen. I'll show you it on. So now, so basically understand few things first and then we'll look at the photo so that you will understand it in a better way. So there are 4 suits. All right. There are 4 suits. In card, there are 4 suits. First one is, anybody knows the name? So there is heart, there is diamond, right? There is heart, there is diamond, there is spade, which looks like this, and then there is club, all right, which looks like this. All right. So these two are black in color, and these two suits are red in color. Is that clear? Is that clear? Is that clear? Right? Now we have 13 cards of each suit. We have 13 cards of each suit. So 13 of hearts, 13 of diamond, 13 of club, and 13 of spade. So in total, we have how many cards? 52 cards. We have 13 cards of heart, we have 13 cards of diamond, we have 13 cards of spade, we have 13 cards of club. Right? Now, what are these 13 cards? These 13 cards are, let me use some other color. I don't think so this is visible. No, right. Where is brown color? Is there brown color or purple color? Okay, so there is A, there is 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, there is a jack, there is a queen, there is a king. All right, there is jack, queen, king. Did you understand? So we will have heart cards. When I talk about hearts, so we'll have A of hearts, we will have 2 of hearts, we will have 3 of hearts, 4 of hearts, so on, J of hearts, Q of hearts, and king of hearts. All right, when I talk about diamond, we'll have A of diamond, 2 of diamond, 3 of diamond, 4 of diamond, and so on. We'll have J of diamond, 10 of diamond, 9 of diamond, everything is there, Q of diamond, and K of diamond. I hope that's clear. Is that clear so far? Then we have spade. So Anu is saying spade. So let me draw spade. So A of spade, 2 of spade, 5 of spade, 6 of spade, and so on. Right? My spade is not looking beautiful here, but that's okay. Then comes club. So you will have A of club, 2 of club, 6 of club, 9 of club, and so on. Fine. So that's how you will have how many cards? 52 cards. 13 cards in each suit. Is that clear so far? Is that clear? Yes. Now let me show you the image. So you see this, if I can zoom this one maybe. Okay, I can. I hope you can see this. So this is club. Club. Can I write on this? I cannot. I have to use annotate, but I'm not using. So A of club, what happened? Oh, magnificent, more magnificence. All right. So A of club, B, 2 of club, 3, 4, 5, 6, 7, J, Q, K. All right. Then you have diamond. Then you have spades. These are spade. Black color even are spade. And this red color one is heart. Fine. Is that clear? Is that clear so far? Now, can you tell me which all cards has face or which all cards have face? Which all cards have face? Can you tell me? Which all cards have face? Which all cards have face? Can you see some face here? J, Q, K, J, Q, K, J, Q, K, J, Q, K. So J, Q, K are face cards. All right. Yes, you have 12 face cards, 3 in each. All right. And ace is considered as, I'm sorry. Anyway, I hope you understood. So we'll move to the question site again. New share, this share, share, share. Okay. So what I was saying was, let me use different color pen, color pen. J, Q, K are face cards. And A, J, Q, K are honor cards, higher ranking card, honor cards, HONO, honor cards. All right. A is considered to be as the highest ranking card. Got it? Did you understand now? So reply to me quickly. How many cards in each suit? How many cards in each suit? 13. How many suits we have? How many suits we have? 4. What are the names of those 4 suits? What are the name of those 4 suits? Heart, diamond, club, and spade. Okay, awesome. Now, how many face cards we have? How many face cards we have? 12. 3 in one suit. So 12 overall. How many honor cards overall? Honor cards 16. How many number cards overall? How many number cards? How many number cards? 40. No. No, not 40. 36. Right, Michelle. So 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the 9 number cards in each suit. So 4 suits are there. So 9 into 4, 36 would be your answer. I hope that's clear to everyone so far. Yes. Okay. Now, if one card is drawn at random, your denominator will be what? 52C1. One card drawn at random is drawn at random. Your denominator will be what? 52C1. If 2 cards are drawn at random, what will be your denominator? What will be your denominator? Come on. If you are withdrawing 2 cards, your denominator will be 52C2. Awesome. 3 cards are drawn at random. What will be your denominator? 52C3. Nobody asked question on 3 cards actually. All right. So the question will be on 52, 1 card or 2 cards maximum. Now answer few questions. So it is like you are withdrawing 1 card at random. Okay. How many card at random? 1 card at random. Probability of probability. Okay, I'll write it. 1 minute. Let me ask the question first. Probability. So wait, people, I haven't asked the question and you people are answering. 1 card are drawn and random. Probability of first case, a red card. Let me see how many of you will get the answer. A red card. One by 2. Correct. Very good. So we have 26 red cards. 13 of diamond, 13 of red. So from 26, we are selecting 1. So 26C1 by 52C1, which is nothing but 26 by 52. So your answer is 1 by 2. Okay. Second one, a diamond card. A diamond card. 13C1 by 52C1. So 13 by 52. 1 by 4. Okay. 7 of club. What would be your denominator? What would be your answer? 7 of club. Okay, 7 of club. What does it mean? 1 by 52. Good. We are withdrawing only one card. Now that has to be 7 of club. How many 7 of club we have? Only one 7 of club we have. How many sevens we have? We have 4 sevens, 7 of hearts, 7 of diamonds, 7 of clubs, 7 of spade. Out of that, how many 7 of club we have? Only one. So your answer will be 1 by 52. 1C1 by 52C1. Did you understand? Got it right? Okay. All right. Now, if I say what is the probability of it being a queen? Queen. What is the probability of it being a queen? What would be your answer? 4C1 by 52C1. Awesome. All right. So I hope you understood that one card questions will be fairly simple. Let's discuss two cards question. We'll discuss one by one. So from a deck of cards, you have withdrawn two cards. Two cards are drawn at random. What is the probability of, if two cards are drawn at random, what is the probability of queen and a king? So one queen and one king should be there. No, Aditya, can you answer in terms of NCR? What will be your denominator in each question if two cards are drawn at random? So if two cards are drawn at random, what will be your denominator in each question? Two cards are drawn at random, two cards are chosen at random. What will be your denominator? 52C2. So every question divide by 52C2, 52C2. Everywhere it will be 52C2. Yes, Surjo, good. So a queen and a king. How many of you are thinking 8C2 by 52C2? How many of you are thinking 8C2? No, right? Yeah, it will be not. Because when you're saying 8C2, now I want you to imagine there are there are four kings and four queen cards. There are four king and four queen cards. So together you got 8 cards. Now, if you're selecting 2 cards, might be possible both are king, or might be possible both are queen. Are you getting my point? Might be possible both are king, or might be possible both are queen. So that's why it has to be one king and one queen. So one king can be chosen from 4, so 4C1. One queen can be chosen from 4, so 4C1. When you choose both king and queen, your event will get over. That's why multiply. So 4C1 into 4C1 divide by 52C2. How many of you want me to repeat, or it's clear? It's clear? Okay. Is my voice audible, people? Am I audible? Yeah, thank you. Okay, so I hope the first one is clear. The answer will be 4C1 into 4C1 by 52C2. Now, both cards as red cards. Second one, what would be the answer? Both cards as red cards. How many red cards we have? 26C2 by 50C. Absolutely right, Rahul. 26C2 by 52C2. That's correct. 26 red cards. Out of those 26 red cards, we need to choose 2 cards. So 26C2 by 52C2. Fine. Third one. Both cards as face card. How many face cards do we have? 12C2 by 52C2. Righto. 12C2 by 52C2. Both cards as space card, 12C2 by 52C2. Fourth one, both cards as honor cards. Both cards as honor cards. Hilda, I hope you are understanding. Subhash, Sivan is replying. Sandali, you are not replying. Raj Bhaumik, you are not replying. Kamlesh Yadav, what happened? You are in some different mode. Vivek, you are also not replying. And Yui, I hope you all are understanding. 1 by 13. Both cards says honor cards. How many honor cards we have? How many honor cards we have? 16, right. So both cards. It means that your answer will be 16C2 by 52C2. Right, Jennifer. 16C2 by 52C2. Okay. Now tell me the answer for the fifth one first. It's all right, Sandali. I think that's the easier one. If you understand cards, then these questions are not difficult at all. Isn't it, people? I'm getting answers from many people actually. So it seems that they are understanding. Anu, yes, Liason, Jonathan, I hope you're also understanding. HM Rehan. Okay, so now 7 of spade. Just now we have solved one question of 7 of club. Similarly, 7 of spade. How many 7 of spade we have? Right, Rahul, that's absolutely right. How many 7 of spade we have? 7 of spade. How many such cards do we have? 1. So this would be selected as 1C1. Now, other as club. How many club cards we have? How many club cards? 13, right? So we need one card. One card is already chosen. Two cards we are selecting. So one card is already chosen. We need to select one more card. So that one more card will be selected from 13 cards. So 1C1 into 13C1 by 52C2. That would be your answer. All right. Got it, people? Fine. Question number 6, wait for a while. I would like to explain you one other question first, and then we'll come to question number 6. So a ticket is drawn, a ticket means one ticket is drawn at random from ticket number 1 to 20. What is the probability? What is the probability that it's a multiple of 3 or 5? That's the question. Naresh Kumar, looks like the class is on. I don't know about. Is people class is on? Is class is on, people? What do you think? Yes. Okay. Anybody else? Yeah, I'm just asking. Yes, class is on. Which class? I think this class only, Ashok. No, Rahul. It's a multiple of 3 or 5. 10 by 20. No, Raj. Yes, Rahul. Now it's correct. Okay. Now, what are the multiples of 3? What are the multiples of 3? 3, 6, 9, 12, 15, 18. That's it, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. What are the multiples of 5? 5, 10, 15, 20. All right. So it has to be a multiple of 3 or 5. right? 9 by 20. Now what is happening? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Though you are getting 10, but why we are taking 9? Can anyone tell me? Why are we taking 9? Can anyone tell me? 15 is common. Yes, 15 is repeated. So when 15 is repeated, we will not count it 2 times. 15 is already counted here. I repeat, 15 is already counted here. That's why we will just consider it as one case. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So hence your answer is what? 9 by 20. Now if I have to do it other way around, 1, 2, 3, 4, 5, 6, 6C1, or it could be multiple of 5, that is 4C1. But now how many numbers you are getting common? One number. So one number we are counting it double, that's why minus 1C1 by 20C1. This is your answer. Is that clear? Is this approach clear to you? All of you understood this approach, right? So 6 numbers from 3, multiples of 3, 4 numbers from multiple of 5, but as one number is common, that's why we subtracted it. Now similarly, try this question, getting both cards as black card or both card as kings. Both card as black card or both card as king. Rahul, 2C2. Okay, instead of 2C1 it will be 2C2. Good, very good. So black cards, 26 cards, 26C2, kings. So you have 4C2. Now how many? You are selecting 2 cards. In the previous question you were selecting 1. That's why I'll say that in this question you were selecting 1 ticket, a ticket. So that's why everywhere it was 1, 1, 1. But here in this question, you are selecting 2 cards, right? Getting both cards. So that's why now 26C2 plus 4C2. Now minus also it has to be C2. Now how many cards are common between black card and kings? What do you think? How many cards are common? Which are kings also and black card also? 2 black kings, which are black cards and kings also. So that's why minus 2C2 divided by 52C2. Yes, Cynthia, Amani, you are very late. Got it, people? Is that clear? Again. So let me share the screen again. So, Surjo, what happens is when I see black cards, this first row, and this row will be considered as a black one, the first row and the third row, right? Now you see these 2 kings are black also. Now you see there is an intersection, like they are coming here also, and they are coming in first row also, and they are coming in last column also. Last column is for kings. All right. So when 2 kings are common, we need to subtract that case. So that's why minus 2C2. All right, Surjo. Like whichever is common, we subtract that because we already have counted it. So as 2 cards were common, that's why, and we are selecting 2 cards here, that's why minus 2C2. So I think people, I hope you understood. We are done with, is there any other question? No. So we are done with this. I hope it is clear. We want to solve 1 or 2 ball questions. Let me think about it. So there are 3 blue balls. There are 4 red balls. red balls, and there are 5 green balls. All right, 3 blue balls, 4 red balls. These are balls, blue balls, red balls, and green balls. Fine. If 3 balls are selected at random, probability of first case, all being different color. Second one, at least 2 green balls. Probability of all being different color. What would be the answer for all being different color? 3 color balls should be there. So what would be the answer for the first one? 3C1 into 5C1. Awesome, Surya. So all being different color. It means that one ball should be of blue color, one ball should be of red color, and one ball should be of green color. So 3C1 into 4C1 into 5C1. How many balls you are selecting overall? 3 balls out of 3 plus 4 plus 5. So 12C3. Yes, that's the answer. So see, probability is very simple. Understood? Got it right? On the second one, at least 2 green balls. So it has to be 2 green balls, one some other color ball it could be, or it could be all 3 green balls, right? So 2 green balls, it means that 5C, not, yeah, 5C2. Now other 2 balls could be blue or red. So these 2 balls will be selecting from 7. So into 7C1. There is one more case, Rahul, where all the 3 balls, because they are saying at least 2 green balls. So might be possible that all the 3 balls are green balls. So 5C3 divided by 12C3. Got it? Is this one clear to everyone? Okay. All right. So here we are good with probability questions. Once you understood the concept, you can solve any question now. The only thing is if it comes in exam. If it doesn't come, that's well and good. If it comes, then I hope you will be able to solve it. Fair enough. Okay, fair. Can I see the reply from everyone? Can I see the reply from each and every player in the room? Can we say 5C2 into 8C? 5C2 into 8C. Answer should be same, Surjo. That makes sense actually. No, Surjo, one thing is that in case you are selecting green ball especially, try Surjo, check answer is same or different in both the cases and let me know. Fine, Surjo? You try once and let me know then. Fine, and then we will discuss it in the next class. I'll also remember. So we are done with probability, people. I'll share this PPT in the form of PDF with you people. Okay. So we will, I haven't deleted permutation combination slides also from this because we were just solving all this. Okay. So let's discuss few questions on syllogism. Like I was telling you other day. So we have solved few questions. Is that okay? We'll do syllogism, a few questions. Yes, no. Right. Let me just open the link. Not link. File, the one which I was supposed to use today. Okay, here it is. Durgesh, I hope you are understanding. Okay, so do you remember few questions on syllogism? Same answer? Then it can work because you are taking 8C1. Awesome, Surjo, that works. Okay, all right. So I hope you can see the screen. Okay, why it is not getting. All right, fine. So do you remember all these things? All x is y, we draw it in this way. Some y are x, no x is y, we draw in this way. Some x are y, we draw it in this way. Some x are not y, again we draw in this way. Do you remember this? Yes, very good. So we have solved these few questions also. All right. What we need to do is we need to follow the diagram. All right. And then there were some questions like I can draw this diagram, I can draw this diagram. So we will see all those things like here. This question, do you want me to solve this one again? Or just look at this one? Binay, till first week of May, it's 2 to 4 p.m. From second week of May, it will be 4 to 6. Okay, let's solve this question. Some questions we have solved, right? Like this one. So let's solve few questions quickly. Some actors are singers. Some actors are singers. Let me use different color pen so that you will understand that the one which I'm explaining now. Okay, some actors are singers. Some actors are singers. Some I draw it in this way. All the singers are dancers. All the singers are dancers. Now conclusion, some actors are dancers. So this part is actor, singer, dancer. So some actors are dancers. Yes. No singer is actor. There are some singer who are actor. So this one doesn't follow. Hence your answer was first statement. Did you remember this now? Surya, I hope it's clear. Right? So we have solved some easy level questions like this, right? This one also we have solved. Now let's solve some these questions. Yeah, let's solve. Do you want me to solve one for, shall we solve one together? Let's solve one together. I'll use different color pen. Which color pen? Color pen. All carrots are birds. All carrots are birds. So all carrots are birds. Some telephone are carrots. Some telephone are carrots. And all bed sheets are telephone. Now there are two cases possible. Somebody can draw bed sheet here only. All bed sheet are telephones. Agree? Agree? Yes or no, people? Or somebody can draw, this is T, and they're saying all bed sheets are telephone. So somebody can draw like this also. All bed sheets are telephone. Got it? So now here I'm getting two parts. So I'll go with like where it is all correct. All bed sheets are birds? Absolutely not. These are bed sheets. I'll write SB or BS. Not bullshit, bed sheets. Some bed sheets are birds, maybe, may not be. Maybe, may not be. right? So this is also not. Some birds are telephones. They are saying all birds. No, no, no. Yeah, some birds are telephone. Yes, possible. Some birds are telephone. Possible in both the cases. So yes, some birds are telephones. All telephones are birds? No. All telephones are birds? No. So the answer is what? Only third follows. Got it? Okay. So now, had I been at your place, what would I have done? Either I'll draw two diagram, or in my mind only I'll think, do you want me to use red color pen only, or this color is okay? Give me your opinion quickly. It's okay. Blue color. Red is good. Even I'm so comfortable in red color, red color, red color. Okay. All right. So red got more votes. So I'll use red color. Now think again, people. If I have to draw it in like this, all carrots are birds, all carrots are birds. Now, some telephone are carrots. So some telephone are carrots. All bed sheets are telephone. Now, when they say all bed sheets are telephone, it means that it could be here, all bed sheets, or it could be here somewhere. So I am confused. Like two possibilities. So all bed sheets are birds. If I draw here all bed sheets are birds, then too I'm not getting that. So first one is absolutely wrong. Some bed sheets are birds, maybe, but I am not getting it. So I'm confused. I'll ignore it. Like you remember, I said whenever you are confused, you should ignore it. So I am getting some bed sheets are bird. No, I am not getting some bed sheets are bird. So we will ignore it. Some birds are telephone. Yes, some birds are telephone. Correct. Some birds are telephone. So this is right. All telephones are birds. What they are saying? No. So that's why it is not the answer. Shall we move to the next one? Okay, I am moving to the next one. Let's try. Let's solve this one. Most CPUs are keyboards. Most CPUs is nothing but some. Some. Most is nothing but some. Most CPUs are keyboards. So some CPUs are keyboards. No keyboard is a mouse. And all mouse are CPU. All mouses are CPU. So all mouses are CPU, and they're saying no mouse is what? Keyboard. So then this is contradictory here only. Third one, some keyboards are CPU. Yes, correct. All CPUs are mouse. All mouses are CPU, so all CPU cannot be mouse. So this one is wrong. No mouse is a keyboard. They have given that no keyboard is a mouse. So yes, no mouse is a keyboard. This is also correct. Some mouse are keyboard. I don't know. When they're saying no, it means no. So the answer will be what? No mouse is a keyboard. Some mouse are keyboard. Some no mouse keyboard. Actually, answer has to be either third or fourth. Either third or fourth. I'll tell you why. And one follows. This should be your answer. Fine. If you don't understand, leave it. I'll come back to this question. As of now, let's ignore it. I'll try to explain you with some easy question. Fine. As of now, let's ignore it. Okay, let's solve this question. All samosas are jalebi. All jalebi are tikki. And all tikkis are barfi. These are sweet dish. This is sweet dish in India. This is some snacks in India. This is sweet, and this is again snacks, which are unhealthy, junk food. Okay, so all jalebis are burfis? Yes. All tikkis are samosas? No. Yes or no? I hope you are understanding. I hope I'm not explaining to myself only. Not understanding, Surjo. Shivani. Answer is no. Okay, fine. Okay, all samosas are barfi. Yes, all samosas are barfi. Yes, all barfi are jalebi. No. Had it been some barfi or jalebi, would have been right. Okay, thank you, Jennifer. Had it been given or some barfi or jalebi, do you think so? That would have been right. Mouth-watering question. I do understand, Rahul. People, yes, here answer is 1 and 3. I agree. But had it been given some barfi or jalebi, don't you think so? That would have also been right. Some barfi or jalebi. Make sense? Correct. Okay. So here the answer is 1 and 3 follows. 1 and 3 follows. No, not this. This option. But had it been given some barfi or jalebi, that would also be the answer. Why would that be answer? Because first and third follows, Ashok. Anindya, sorry. Anindya, first and third are following. That's why first and third follows. Okay, Anindya? Okay. All right. Some eyes are ears. Some ears are lungs. All lungs are hands. Okay. Draw it in this way. Whenever it's some given, draw it in this way. Now, some hands are eyes. Maybe, may not be. I am not sure. I'll ignore. Some hands are ears. Yes. Some hands are ears. Yes, no. Yes. All right. Some lungs are eyes. Some lungs are eyes. Maybe, may not be. I'm not sure. No hand is eye. I don't know. Maybe, may not be. Because if I draw here, then it maybe may not be. Okay, so that's why I'm not sure. How many of, is there anyone who has a confusion in this? No hand is eye. Is there any confusion in this or it's clear? If it is confusion, type CO. If it is clear, type CL. Because unfortunately, both the words are starting with C. Clear. Okay. All right. So the answer is only second follows. Okay. Fine. I will give you this as a homework. One more we will solve. And then I want to move to one other question. All liquids are solids, some solid are gases. All. Okay, now you try. I'm not trying. First you try. I hope you would have drawn like this way. All liquids are solids. Some solids are gases and all gases are clouds. I hope you have drawn in this way only. Now some clouds are solids. Yes. Some clouds are liquids. I don't know. Maybe, may not be. I'm not sure. Some gases are liquids. I'm not sure. As of now, I'm not getting. So maybe, may not be. I'm not sure. Some solids are clouds. Some solids are clouds. Yes. So do we have first and fourth follows? Yes, that's your answer. Okay. Fine. All right. Now I would like to explain you one new thing here. Then we will come to all these questions. Fine. Now everyone stay highly focused. because very easy thing is gonna come on your way. Some birds are goats. Some birds are goats. Some goats are horses. Yo Binay. Some horses are lions. Some lions are tigers. This is one. Now, people understand one thing. When somebody is saying some birds are goats, now everyone stay highly focused. Like I'm telling you again and again, because there is something very easy on your way. Some birds are goats. So now somebody can draw it in this way also. Some birds are goats. So here birds and goats. Now some goats are horses. So somebody think the goats which are here can be a lot, the horses also. The goats which are here could be a horses also. So this part could be a horses. I'm talking about this part. Now they are saying some horses are lions. So somebody can think that the horses which are here could be a lion also. Are you getting my point? Birds, goats were here. So whichever goats are here could be a horse also. Whichever horse were here could be a lion also. And whichever lion was here could be a tiger also. This is called as international diagram, right? So that's why we don't have to solve this. Now, that's why now we have two diagrams, diagram 1 and diagram 2. All right. Conclusion 1. Some tigers are goats. Some tigers are goats. Yes or no? In the diagram 1. Some tigers are goats. Yes or no? Quickly, quickly. No. No tiger is goat. 1 minute, 1 minute. Conclusion 1 only. Some tigers are goats. No in first one. Some tigers are goats. Yes or no? In the second diagram. Yes or no? Yes. Conclusion 2. No tiger is goat. Diagram 1. No tiger is goat. Yes or no? Tiger is here separately. Goat is here separately. Yes or no? 1 minute. No tiger is goat. Yes. No common link between them. Yes or no, people quickly reply. Only one person is replying. That's Surjo. Jennifer. Thank you. So no, Jennifer. Goat circle is ending here and tiger circle is starting here. They don't have any common link. So no tiger is goat. Yes, it is absolutely right. But when I look at the second one, no tiger is goat. No tiger is goat will be a wrong. So now what is happening? Whenever you have some no, tiger goat, that is some xy and no xy. Your answer will be what? Either or. Either first conclusion or second conclusion. Because when I take first conclusion, diagram 2 will be correct. And if I'm taking second conclusion, then diagram 1 will be correct. And nobody can say that both are not correct. All right. So very simple thing you have to do whenever you have some no, like in one of the question which we have solved. I remember we have some no here. We have some and we have no, right? Mouse keyboard, mouse keyboard. Your answer would have been either 3 or 4, like I was telling you. I repeat. So whenever you have some no, your answer will be what? Either or. All right? Either or. These two has to be same. Is that clear? Is that clear, people? Yes. Now look at this. Some no. Lion bird, lion bird. My answer will be either 3 or 4. Here also my answer will be either 1 and 2, 1 or 2. So my answer will be this option. Either 1 or 2 and 3 or 4 follows. Got it? Let's move to the next one. Now, all flowers are fruits. All flowers are fruits. All trees are leaves. And some fruits are leaves. So some fruits are leaves and all trees are leaves. So all trees are leaves. It could be here, it could be inside here also. I hope you are getting it. Now, some trees are fruits. I'm not sure. Maybe, may not be. Some leaves are flowers. Some leaves are flowers. I'm not sure. Maybe, may not be. Some trees are flowers. Maybe, may not be. No flower is leaf. So now you see flower, leaf. Some no. So my answer will be either 2 or 4 follows. This would be my answer. Did you understand? I was not getting a unique answer. I was confused in every statement, every conclusion. Some trees are fruits. If I draw it here, then no tree is fruit. If I draw inside, then there are some trees, but I'm confused. I'll ignore it. Some leaves are flowers. As of now, I'm not getting some leaves are flowers. So again, I'll ignore it. Some trees are flowers. Some trees are flowers. I'm not getting it. If I do some circus, I might get it. But as of now, I'm not getting, I'll ignore. No flower is leaf. Yes, no flower is leaf. Maybe, may not be. Who knows? If I draw this leaf here, because some fruits are leaves, if I draw here, then maybe. So some leaves are flowers, no flower is leaf, none. Some no, leaf flower, leaf flower. XY has to be same. Answer would be either or 2 or 3. Now, same way. The moment I look at the question, I will get the answer. All shirts are chairs. All shirts are chairs. Some chairs are rats. Awesome, Jennifer. I was looking for your reply. Some chairs are rats and all rats are pens. Some pens are shirts, maybe, may not be. Some pens are chairs, yes. Some pens are chairs for sure. Some rats are shirts, maybe, may not be. No pen is shirt, maybe, may not be. So this one is following. Second one is following. And some no. Pen, shirt. Awesome. 1 or 4. So my answer will be C. Got it? You people are, I hope you people are not in any shock. You people understood. Michelle, Mercy, Mukaha, Mardi, Kumbuso. I hope it is clear. Dipesh, I hope it's clear. No, ma'am, clear. What you are saying, Mercy? You are saying no, ma'am, clear. Okay. With that space, I thought so. It's clear. Okay, can you tell me the answer of this one quickly then? Awesome, Afreen. What's the answer for this one? A. I think B is the answer. Some sweets are chocolates. Some chocolates are means. Some means are food. Some food is diet. This is a similar question we have solved. Some diker, goat, horse, lion, something like that. So I just have to look for some no. Some no. No, some. So food chocolate is not there. So this get eliminated. Sweets are diet. Sweets are diet. So my answer will be this or this, either 1 or 3 follows. Yes, Jennifer, B is the answer. Surjo, I hope you understood, right, Surjo? Yeah, B is the answer. Fine, people. So I hope you can do these questions now. Let's solve one more question. I hope it's clear. Let's solve this question. Right. So did you understand the concept, how to solve this type of questions? That's more than enough. Awesome. Okay. Some messages are WhatsApp. Some messages are WhatsApp. All hikes are WhatsApp. And all WhatsApp are Facebook. All right, Shivani, let's see. Some Facebook are messages. Yes. All hikes are Facebook. This is also possible because all hikes are WhatsApp and all WhatsApp are Facebook. Right, Shivani? Yeah, so this is also possible. Some messages are hikes. Now, I will say this maybe may not be, because if it is only here, then I am getting no message or hike. The way I have drawn here, I'm getting no messages hike. Agree? So third one cannot be your answer. Third one is incorrect. Some messages are Facebook. Some messages are Facebook. Yes. So this is correct. So answer has to be 1, 2nd, and 4th follows. Yes. Third one is the answer. All right. Right. Awesome, Jui. I hope you understood. Awesome. Rehan, very good that it's clear to you. Yeah. If anyone have confusion, draw two diagram. But I will say don't draw. It's okay. Pretty easy. All right. When you get it, us yes, Anandya. Fine, people. So we are good with this. Are we good with this? Are you good with this? Yeah. So today I'll share this also syllogism PDF and probability questions PDF also. Fine. So tomorrow you have verbal class, and day after tomorrow we will be meeting. So day after tomorrow we will be doing clocks and calendars because that's what you people want to discuss. So let's do that also. Clocks and calendars. Fair enough? Okay. One more thing, the class is from the next week of May, that is from the second week of May. Second week of May is from second week of May. Equation question we will do. Dipesh, don't worry. All right. From second week of May, Monday to Thursday, the timings will be from 4 p.m. to 6 p.m. All right. Friday will be a holiday. Friday will be a holiday. We were thinking that Friday we will keep class, but Friday is a holiday. Saturday timing will be 2 to 4 p.m. Indian Standard Time. All right. Somebody wrote me a very big message. Thank you, Afreen. Thank you. You to take care. Is everyone clear on this? 5 messages. Yes, fine. Okay. All right. Fine, people. So take care. Bye bye. We'll see you again. Okay. So we'll see you on when? We'll see you day after tomorrow. Thank you, people. Love you too. Bye-bye. Enjoy. We'll see you on Wednesday. So do you want to discuss clocks and calendars or you want to skip it? Aditya, you want to discuss? Discuss. Okay, we'll discuss. Fair enough. We'll discuss. Okay. Bye-bye, people. Take care. Enjoy. Have a lovely day, rest of the day. I am ending the meeting.